I'm very pleased to introduce Mischa Dohler, whom I've known for many years based on different interactions in Europe. And we're happy to now have him in the US as a chief architect at Ericsson. And just a couple of words about his previous background. So as many of you know, Mischa, before this was a professor of wireless communications at King's College, where he also ran the wireless center that has been there for many years. He has many awards and distinctions. He's a fellow of the IEEE Royal Academy of Engineering, Royal Society of Arts, and I guess most importantly, he is a well-established and recognized composer and pianist who has several albums on Spotify, so if you'd like to check those out after the talk. He's also a member of the Spectrum Advisory Board of Ofcom, which is the UK regulator for spectrum use. Just to end the introduction, he is cited as in many roles, and he has been editor-in-chief of several journals, and he is a top 1% cited scientist across all fields globally. So with that, let me welcome Mischa and ask him to take over and give the talk. We have about 1 hour for the talk, including Q&A, which would be nice to have some Q&A at the end of the session. Thank you. Please go ahead, Mischa.
Fantastic. Thank you. Thanks so much for a wonderful introduction. It's a pleasure being here. I'm joining from Silicon Valley. I went to the offices, actually. And I thought today I'll talk you through this innovation journey into a 6G future. And I thought that would interest you as an academic community. But really, ulteriorly, I wanted to ask the question, what's going to be the next internet? So if you think about it, we have been so successful in designing different versions of the internet. We built first a fixed internet, and then we said, hey, this is great, but let's make that untethered. And we ended up designing the mobile internet, which is part of our journey here in the wireless community. And then we thought, what else can we connect apart from our mobile phones? And we said, why don't we connect things? And we started to build the things internet, which we refer to as the Internet of Things naturally. And the question is, what's the next internet, right? So that the internet which comes after the things internet. And yes, we will have loads of enablers. We will have loads of boxes. We'll have millions of lines of codes. And part of that was already presented to you in the morning. Other stuff will be presented to you after my presentation. But the ulterior question is, where does it fit in, right? So what are the building blocks really contributing to? And I think it will be a future where we really be able to, to really enable skills. And I want to talk you through this. So I hope you see the slides or the video. So this is one without sound. It will loop for a while until I stop it. What I think we really agree on is that we see a future which will be fully immersive. Right, so a fully immersive internet. Today, we are able to transmit video and audio, and we can do loads of things, read the news and emails and all that. But one thing I can't do today is I can't touch you through the internet. I can't actually, execute my muscle power to move objects or to do certain skills jobs, which we do naturally when we are together in the room. So therefore, I think, our ulterior game should really be, let's design an internet which is sufficiently immersive such that we are able to execute skills remotely. So think of a world where, if you have problems with your plumbing at home, rather than calling a plumber, that would be executed remotely. If, I want to teach somebody how to play the piano, I can do that without actually leaving my house. And this will be enabled, by the networks, by AI, by haptic devices, you name it. And that journey, that journey from where we are today to this internet, I would like us to build within the next decade. That's the journey I would like us to talk through. And let's assume for 1 second that we succeeded in building an internet like that. What would it democratize? Each internet has democratized something. And, arguably, the internet so far has democratized knowledge and information. what is that internet going to be democratizing? Well, skills, right? So the ability to really bring in skills from any part in the world to any other part in the world will really democratize the way how we execute skills, how we upskill people, how we teach and train people. As an example, in King's College, we have been exploring on how to teach surgeons to really do surgery, how dentists could actually learn through haptic feedback, really how to do the correct dentistry operations, because doing this on video is one thing, but actually experiencing that with the haptic feedback, so both touch, tactile, as well as kinesthetics, the muscle movement, right? So haptics has always these two components, right? So how do we go about this? Well, if we look at it, we really need a very fundamental shift. And when I look at these shifts, I like to zoom out and look back and try to understand what has really shifted significantly in the past. And if you look at the internet has not emerged overnight. It actually took us quite a while to build, but there are two innovations which stand out, which really enabled the internet today. And one of them is, of course, networking. We have flattened networks. So we invented IP. As long as the machine would speak IP, hey, we're good. You know, they can actually contribute to this digital fabric. But there's one thing people forget. We also invented codecs. So, you know, I can today take a picture or a video on my iPhone and I can play it on my Dell computer, something which wasn't the case before. So therefore, it is not only about the network, it is also about the devices and the standardized codecs which run on these devices. And we put it all together and suddenly we had this explosion of the internet economy. Now, if we want to do the same in the internet of skills, we just follow the blueprint, right? So we don't need to reinvent the wheel. We look at what we have today. Do we have devices today which are proprietary and expensive? Yes, we do, right? So look at robotic edge devices. There's other stuff out there. Complete vendor lock-in, right? So if you were to separate, for instance, this is a Da Vinci robot you see here, which we use in King's College to do operations, okay? So surgery. And there's a huge amount of reasons why we would do surgeries using robots. But fact remains is that it's proprietary. If I were to remove the surgeon from the patient over larger distances, I wouldn't be able to do it. Okay, so therefore, to enable that, we need a new internet, and that internet is super low latency. Okay, and we have done our homework already in 5G, but we need to do more. And this is really what I'm driving at in this keynote today. If we really want to build this internet, we need a truly low latency. So that's something we now understand we can bet at. We also need AI. We need tactile codecs. So there's a lot of stuff we just copy paste, Control C, Control V from the top part, adapt it to the lower part, and we let it go, right? So 5G, we started this a few years back, and we're getting better at that. Codecs, you know, I am the co-founder of the IEEE Tactile Internet Working Group, and I actually insisted on founding a tactile codecs group, which currently is very active there, because what I really felt is we need to build these MP3s for touch, right? So that's really, in essence, what we're doing there. But putting it together, that was my hope we would really achieve that. We would really be able to get this internet of senses, this internet of skills really going. But we hit challenges very quickly, very, very quickly, right? So if you look at the latency requirements, human cortex requires a 10 millisecond engagement, right? So, and that is if I, you know, see things and I engage with you when we're together in the room, when I'm doing muscle movements, I'm applying this, I'm playing the piano, you know, things happen within 10 milliseconds in the brain. And surprisingly, you know, I'm not sure you know this, surprisingly, nerves are very slow. So a tactile sense, the touch sense is actually a very slow sense. So therefore, it was a bit misleading to call the tactile internet the internet, which does things very quickly, right? So in fact, from my fingertip to my brain, that signal takes about 120 milliseconds. It's the kinesthetic movement which really requires a very low latency. We should have called it the kinesthetic internet rather than the tactile internet. And you can find it out that when you touch a hot surface and your brain doesn't do the extrapolation, meaning your brain doesn't know it's hot, If you don't know it's hot, you touch it, it takes you a while to realize it's hot. And that's because the nerves actually are very slow. So anyway, things happen within a 10 millisecond horizon. I gave you this one of these black boxes here. Now, if you look at an engagement from London to Los Angeles, you have so many more of these 10 millisecond boxes. In fact, I had to cut it out because it wouldn't fit on my screen. What do we have? Well, we do have the application running. I'm making a Zoom call as an example right now. And, my Zoom codec takes a while to compress the signal, and on the other hand, to actually decompress it. We need time to encrypt it, decrypt it, you name it, right? So there's a software stack built on top, which essentially takes quite a lot of time. Then we got networks, and networks are composed of two parts. One is the one which is the congested part, the yellow ones, and one is what is the physics dictating, which is the speed of light, really. And on the networking part, we are actually doing pretty well, right? So if I look at this now, how do we address that? The yellow part is really being addressed through sliced architectures, right? You have just heard a great presentation by Ivan, and really telling you how things work these days and how it's being orchestrated at 5G level. We can really bring this down to zero if you do that very well for emergency services, low latency service, sorry. That's how we do it. How do we get rid of the green boxes? Well, it's you really need low latency applications, full stop, right? And then down there. So it doesn't make sense to bring your network latency down to a millisecond if your Zoom call, which is put on top, takes about 160 milliseconds. Makes no sense. All right. So therefore, this impedance matching of latencies is one of the biggest challenges I have encountered. And therefore, we started really to work on these standardized low latency applications. Slicing came along really well. And then big question mark, what do we do with these red boxes, right? Physics, very annoying, seems to be very fundamental. So I'm coming to this later because I'm going to put it to you as a challenge, okay? I would like to finish that keynote with a set of challenges which I like you to address. So, but bear this in mind, this is really how it looks like at the moment. It's not only in the networks, ladies and gentlemen, it is actually a whole ecosystem which needs to be addressed. Another big challenge we found very early on is around artificial intelligence, and AI is a real theme of the event today. So I thought I'd just insert this slide here. And when it comes to the more societal thinking around AI, Europe is really leading the way. And I just wanted to share a bit of thinking on what is happening there, right? So in essence, I personally believe we have an observation conundrum. So, and I put a black box there because observation conundrum is actually, we truly don't know whether AI is already so deep in our fabric, whether these are societal applications or telecom applications, that it influences us to a degree that we are actually not aware of, and we actually should be aware of. And it is because we just don't have a platform of observation, right? So when you use your, we know when we're using a mobile phone, we know when there's a camera somewhere in a park or in a building observing you. So we do have this observability, but with AI, we don't. It's all working really in the background. And really, it reminds me of a film called Battlestar Galactica. So those of a certain age on this call here will know that film. And, there's a cyclone lady which lived among humans in the future. It's a film that takes place in the future. So this cyclone lady is a machine, and she was living with humans for decades without them realizing, because they simply lacked this platform of observation. So we need to establish that, and calls for standardized AI, for the ability to monitor AI, really are growing stronger because of that. The other one is the paperclip conundrum, and that really happens when you start service chaining different AIs, okay? So each of us develops a piece of AI, and each of us is a very peaceful researcher or academic or innovator, really trying to make good to the world. But the moment you start service chaining these AIs, you come to a point where actually you don't know anymore what this whole chain as a whole in terms of an emerging behavior will do. And our colleagues in Oxford summarized this as this paperclip conundrum. And they observed, imagine a situation that a very benign, a very peaceful AI in the year 2050 has been tasked to deliver a paperclip to every single human being. Okay, so the engine starts humming, it starts yielding the metal, it gets all the ingredients and starts producing the paper clips, ships it out, it works really well, everybody is happy, they're getting their paper clips until the machine serves about half of the population, let's say 3 billion, and then it runs out of metal, of resources. But it's been tasked to deliver it to humans. So what does it do? It kills the remaining 3 billion, right? So again, you know, the ethics clearly wasn't programmed into the whole machinery. And clearly to make this paperclip in such a sophisticated scenario, you need a service chain. So each service element was very peaceful, put it together, suddenly it ends up at the point where it is actually very bad, right? And we need to be careful, and we need to understand whether this doesn't happen today. Look at the stock markets. Stock markets today are driven by AIs, often pitted against each other. And whilst maybe, you know, the many countries have tier 1 currencies, it doesn't really matter. But second order countries with second order currencies, you know, then there's a deep dip in currency, you know, that may default some of the banks or whatever. So we just don't know what's really the implication there. We need to be very careful. And I always like to remind people that, you know, there's a huge difference between applying AI in a consumer you know, scenario. I'm showing the cat here versus industry. So 1% outage, you know, for a little Google thingy or AWS thinking, trying to detect whether it's a cat or not, makes no difference, right? So, you know, no life is at stake, and maybe the life of the mouse, but I don't know, right? But it makes no difference. It's okay. But really in industry, we do have a problem. And, you know, for the better or worse, you know, the whole AI ecosystem is driven by companies where the 1% outage is the case. You probably have all been using PyTorch and all that, these packages. Now, I have, you know, in London, I had a few companies. We had to work in production environments, and we didn't use any of that. In fact, the Google folks themselves told me don't use it because it's not very stable, not really useful, except for upskilling, learning, having it in your notebook environments, etc. So therefore, I think we need to make this really mental shift to start thinking production-ready AI. And the European Union recognized this and said, you know, in 2018, as part of the GDPR revamp, they really said, guys, if you use AI, you need to be able to explain this. Can you explain today? Can you explain how a CNNs works? You know, GANs, LSTMs, you know, how one-shot learning would perform, how boosters work? Answer is no. You have no clue. You can't do it, right? We can do input, we can do output, we just don't know what's happening in the middle. So my buddies at King's then invented this explainable AI, which now has really grown as a field into trustworthy AI. It's, I think, now the overall term, but it really started out of this thinking very early on, because we worked with industries like Schlumberger, we worked with telco operators. In fact, you know, I was in Orange, France Telecom for many years. We invented deep learning reinforcement learning for antenna tail power control in release 8 when SON came out, you know, and it's kind of all coming back now as a new invention, but we did it back then, you know, in 2005, 2006, it was all there, but Paul Friedel wouldn't adopt it because it wasn't industry compliant. So therefore, coming now back to this, I'm throwing this out to you because I need to think you more industry compliant. What is the convergence, the true convergence? When you show me reinforcement learning convergence graphs, I want to see the true one. Don't average. I want to see the standard deviation, because the standard deviation gives us the instabilities. I want to see the real deal, right? And I want us to develop as a community stuff which is really reliable. What else? The third challenge was around the codecs, and we're addressing this now. So if you tune into the IEEE Tactile Internet Group, where the official acronym is 1918, you have two families, the tactile, the touch, which actually has almost no latency constraints. You know, you can transmit 120 milliseconds, latency makes no difference. So the touch, the tactile part is really no problem. Kinesthetic, that's where we really need to put our hand on. How do you move muscle movement through the internet? And, you know, Pioneers like Eckhard Steinbach from TU Munich is really driving that brilliantly. And I think these will be the new MP3s and 4s for touch and codec. And, iPhone 15, I'm making predictions here, I don't know. iPhone 15, let me take my iPhone 13, right? So iPhone 15 will have a tactile vibrous screen where we will be touching, we will feel when you buy a sofa, you buy a cushion or a jacket, you can actually feel it whilst you touch it, right? So because we're developing these codecs, right? It has to work together. So we build it all together, and we started looking at how do we really make sense out of this. So addressing the challenges, we addressed some of the challenges, we evolved 5G, we standardized it, we started to look into orchestration platforms, ONAP and Etsimano. You've heard of some of them, but how does it all fit together? All run started and growing, and from Ericsson's point of view, the journey was very clear. The roadmap was very clear, saying, look, we need to softwareize our ecosystem because it was very monolithically built with millions of lines of codes and boxes and wasn't very flexible and not even flexible for us as a company. So softwareization was the first step. That was achieved, so tick, right? Next one was to cloudify that, to give flexibility in terms of where we place functions, where we place that software. That's happening now with the Cloud Run capability in Ericsson Tick, right? So we know that, of course, as an academic community, we have worked on this for many years, but I remind you, there's a huge quantum leap between something where you play around and then something which is really production environment. Huge difference, right? So think of it as the journey from a Raspberry Pi to something which is a high-spec hyperscale environment. So therefore, for educational purposes, Raspberry Pi and PyTorch and just throwing in stuff, which I find very useful. Yeah, it's fantastic. I could upskill my students, but industry, of course, can't use that. So therefore, I think that leap which Ericsson did to Cloud Run is really, really important and is successfully executed now as part of the 5G rollouts. The next thing is really to see, hey, how can we create value now that we have cloudified that? And All Run has happened. And it's a great movement, okay? It's a really great movement, and particularly, let's say on the top, not over the top, but on the top innovation is something I think we as a community all want to achieve. And in fact, Ericsson, I find it very ironic that, that the vendor is really driving the production-ready capabilities of ORAN. But, we are the only vendor at the moment who has really a production-ready service management orchestration platform, which is ORAN compliant. And the magic is in the RApps, right? So the RApps which sit on top, which really allow you to do a lot of AI. Think of it as a telecom app store, which sits on top and which we really want the community to participate to help us make these systems more efficient and effective. Now, the big question is always, how deep should we go into plumbing? Right? So how deep should we really go and open up the systems? Well, look at these successful ecosystems like the hyperscalers, right? So Google doesn't open up their plumbing. They don't, right? So AWS doesn't, Azure doesn't. So the notion of an XApp in these hyperscale environments doesn't exist, okay? It doesn't exist because they realize that they're really jeopardizing performance. I'm telling you this now as a non-academic, but really as an industry person. You really jeopardize performance and scale, and there are loads of other things. So therefore, I think the focus of the community now in production environment, so teaching environment is a different story, but in production environment should really be on the top RApp App Store kind of capabilities, right? So that's very, very exciting. And of course, that Ericsson is very active in ORAN on that. Now, what did we do? Like before I go to the next slide, so we put it all together. I showed you here the Ericsson stack. I had a hybrid King's Ericsson stack, and we started to roll this out. And I had a very personal experience, and maybe some of you know this. I did this world's very first 5G distributed concert, right? So I'll show that to you here. I hope the sound works. So what happened here, right? So you see me, this is 2018, okay? So, it's just really, we're just freezing the specs, and we were the first ones to really get a 3GPP compliant system up and running. I'm sitting in Berlin under the Brandenburger Tor playing the piano, and that young lady is in London in the Guildhall, and the Guildhall is UK's oldest entertainment venue. And we thought, why don't we marry this very young and exciting technology called 5G with this very, very kind of historic entertainment venue, which the Romans brought to London 2000 years ago. So the Romans knew, the Italians always knew how to party. So we had this young lady there, and she's my daughter, actually. So Noah, my older daughter, and she really loves singing. When we lived in London, we moved now to Silicon Valley, but she would often sing in the Royal Opera House. If you're into Madonna, she sang with her on 2 songs on her last album, Madame X. So she loves it. And we thought, hey, let's do something which is very emotional. And I maintain, as engineers, we're not very good in bringing the emotions out of the technology. Give technology a soul, right? We're very good in explaining architecture slides and writing lines of codes and building boxes and all that. But really explaining to society what's the value, we really struggle. So we thought, let's do this. Let's really take father and daughter 1,000 kilometers, 800 miles apart, and bring them together. And I had Noah with me there. She was being with me 20 milliseconds. We didn't get it to 10 or 1 millisecond, but 20 milliseconds latency round trip time. And it felt like she was with me. Okay, I was so emotional. I was literally so emotional. I struggled not to cry whilst I was playing, because we actually did something which nobody else did before. So forget about your Zoom calls, forget about your Teams calls. This is really, this full immersion, this full immediacy. This is like being together again in the room without actually being together. And this is where I saw for the very first time the power of low latency. Okay, so people talk Industry 4.0, that's all good. But really what's going to hit us as a big breakthrough is that low latency. So yeah, it's fascinating. And then, the industry started building on this. There are loads of use cases now doing music stuff. AWS, did one recently again. Vodafone did stuff. So, the ecosystem is building up, and it's great. That's really what we wanted. We wanted really to give really this food for thought, the other way around, to really start building, thinking as a platform, right? As a platform which everybody has access to. And then, of course, industry started to productionalize it. So Ericsson did some amazing stuff. In fact, I had to choose from literally, more than 200 slides on what Ericsson has done in terms of production-ready deployments around the world. And I just extracted 3 of them. So one of them is really with Mercedes-Benz Factory 5G, repeated all over the world, including in Illusion in the United States, all over Europe, Asia. It's really about flexibility. So the ability to have your 5G provide and replace essentially the cable they use is a real game changer. And you will agree with me, you probably will have no emotions to factories, but you have emotions to your own laptops. So in the morning, I just have 2 laptops here, and taking out these cables is a mess. So multiply this by 1 million with all the machinery in the factories. Having the ability to do this wirelessly gives huge flexibility. Robots can move, you can replace stuff, you can really start building, factories which can do stuff on demand, to the point that when the future, when you wanted the car, which looks really personalized to you, you order it online, it's being manufactured to your liking straight at the manufacturing line, because we're able to reconfigure these computers, right? And robots. So therefore, the ability to do this low latency stuff, they really need milliseconds latencies forth and back, because these are control loops, a lot of safety there, production ready. So I'm really emphasizing this here, and that's really what Ericsson has achieved. Then in the area of, this Internet of Skills, the ability to transmit skills remotely, we partnered with a fascinating ecosystem, which really allows you to remotely essentially move robotic arms, right? So you would do that with a joystick or with an exoskeleton and start really moving remote equipment. And again, you need this, millisecond latency round trip time, which is being facilitated over a distance of 1.5 kilometers here. What else did we do? Well, we then started really looking into, empowering humans. Like I call that human 4.0, okay? So because people understand industry 4.0, but I always felt that, we really should not only empower machines with our technology, but we also should empower humans, right? So the ability for humans to become stronger, to be safer, to do stuff that weren't able to do before. And, as part of this Human 4.0 kind of initiative, how can we start programming and influencing and supporting exoskeletons? So therefore, this edge device community goes well beyond these days, mobile phones and maybe augmented reality glasses. We are really starting to tap into the muscle movement and the tactile and the haptic, environment or fabric of the human body. So this is going to be really stuff to appear probably 2030. So this is now for industry. Typically, industry takes it first, and then it's being fired into the consumer market. So get prepared to get something like that in 10 years' time, right? The Iron Hand. So you will have heard it from Mischa in 2021. And as we are on this journey, we are now looking to start to look into 6G, right? So how is 6G going to look like? And is it important to do it? Hey, we have done 5G, and now we're rolling it out. It's important to do 6G. And the answer, is often, in the economics really. And this is how you get government excited, industry excited. You don't get necessarily as excited, but I wanted to show you these numbers, right? So for the United States, CTI did an estimate how much money was really added, because of 4G. And the variation is horrendous. As a data scientist, you look at it, 200 billion to 700 billion. Is that like 300% standard deviation on the standard deviation? I don't know, right? So, but you understand it's a huge add-on. So it's at least $2 billion per month added because of 4G. Now in the 5G era, they can only project this in the future. Currently, they're projecting this as 1,500 billion, so 1.5 trillion. This will be 12 billion per month. So therefore, also, that's important because, we need to understand we shouldn't be delaying 5G rollout. So that FAA, FCC, discussions going on is a real problem because we are losing, essentially 12 billion GDP every month. We're not deploying 5G. So therefore, we need to get about it. And therefore, we don't want to be late on 6G. You do the number crunching, you can extrapolate it yourself. We have typically good trends. So assuming we go from 1 billion in 4G to 10 billion in 5G, it will be 100 billion per month in 6G. So therefore, every month will have a huge economic impact, and we need to get it right. But it takes time, right? We all know this. It takes time. We start the green line, we take research, it takes a while for us to really get onto this. And we started to talk about 6G these days. Then standards kick in a few years later, and then really the production ready deployments kick in. So in that, that horizon is typically 10 years. And annoyingly, very annoyingly, despite us having softwarized things, despite us having made them more flexible, it's not getting quicker. You would like to have these, whatever the distribution is. Would that be a Rayleigh distribution, a double Rayleigh? I don't know, right? So we want them ideally to go into a direct delta where things happen very, very quickly in very short time. So that's really our ambitions, but for the time being, it looks like that. So when you look at 6G, you wonder what are the specs at the moment, and you know the specs, right? So we went from a 4G era where we had hundreds of megabits per second. 5G, we now have tens of gigabits per second. 6G, we're looking, what do we need really? And it will be driven by applications, right? So we want to enable really this Internet of Senses, this Internet of Skills I talked you through. We want Industry 4.0 connected machines. We want digital twinning, right? This merge of cyber-physical systems is part of our digital world, right? So these are really the applications which are driving us currently in terms of the 6G design. And, there will always be stuff which is 5G plus. So 6G will clearly make applications possible or better in which we have in 5G. It will also enable new applications, and it will also do stuff which we haven't actually even seen before. So therefore, I always like to have these three camps, trying to understand what do we improve with respect to the previous generation? What do we actually really enable for 6G, which we truly can't do in 5G? And then what are the unknown unknowns, right? So these are the questions we need to answer. And it will impact latency, right? It will impact designs. And from a latency point of view, if you really go into this fully immersive society, this Internet of Skills, we need latencies which are much better than what we have at the moment. And the 10 milliseconds we have currently on our systems, maybe we need to push this a little bit to 1 millisecond. So over the air, the TTIs maybe need to go down to microseconds because we got speed of light processing capabilities. So therefore, the hyperscaler and the comms community, really needs to come together to enable that. So that's the challenge here, really getting the latencies right. Architecture, we need to work further, right? So, and I think Ivan had a great slide. I've seen this, I'm sure there were other presentations before and other great presentations coming in the afternoon. But, that flattening of the fabric is very important, but that's not all of it. Then you need to really start to flatten the AI into this. AI now is an enabler. And Malik, our Silicon Valley CTO, is really arguing that our stack is really now changing significantly. AI needs to be natively part of that. And then you are able, through the RApps and the softwareized networks, to build intent-based networks, right? So the ability to reconfigure in real time to certain requirements, to certain intents. And this is where our networks will really transit to a very human-centric architecture. Right. And that's what I really find so fascinating, a human-centric architecture, because we started with a cell-centric architecture, right? Everything was about base stations. Now we are in a device-centric architecture. So we have a cell-free type of environment because each mobile phone sees so many base stations that it doesn't matter anymore how the cell look like. So we're in a cell-free architecture, but we will transit in the future to a true human-centric architecture, which will be able to operate on intents. What else do we need? Well, we need to get security right. And it's really, really difficult. And, and this is really where ORAN still needs quite a while to go. To get production-ready security is difficult. Point-to-point is easy. Where symmetric, asymmetric, you can find it, what you want. System security is difficult. And you see that with your Microsoft computers. No matter how long we are doing the upgrades, there's always a vulnerability because systems are complex. So therefore, this emerging kind of opening of doors, which you can't anticipate from just having one component secured and another component secured, put it together as a system component, they become unsecure. And I think this is what really Telkom has done so well in really making this as secure as possible. Of course, it's not 100%, but we have one other thing to do, and that is to get the privacy right. So we are working really a lot on this here. And, if anybody's really working on privacy, let us know. I'm keen to hear fresh ideas, so please don't contact me with the stuff we have been exploring for the last 10 years. Privacy by engineering design is what we need. And we have very clear ideas on how to do that. If you want to join that bandwagon, I think that's going to be another big revolution, really, where we will change the way we look at privacy altogether, right? So that's happening. Zero trust architectures is now really part of our thinking. Security is evolving. Telecom has been brilliant at that. Let me finish off now with the challenges, so we have a bit of time to discuss as well. So the challenges I see, apart from the privacy challenge, okay, there are three challenges. I really would like us to start thinking, how can we prepare the entire ecosystem, okay, the entire ecosystem for what I call a machine age. And why do I call the machine age is, well, just look at the mobile data volume, okay? In 5G, we have a data volume of about 10 terabits per second per square kilometer, meaning our 5G systems are able to either absorb or generate that type of traffic. Now, 10 terabits per second per square kilometer. Can you imagine that? I can do that, right? So if you think of a high stack building in New York or in Hong Kong or in Tokyo, now they are known in Silicon Valley. So I'm giving you New York as an example. Loads of people together doing everybody's doing cloud gaming. You will end up with these densities. So, humans can use that. Now, 6G, if you do the number crunching, virtue by extrapolation on how our data rates and the number of devices we can connect to systems really will go from 5G to 6G, you end up with 10 petabits per second per square kilometer. Can humans absorb this? Guys, I sat down, I calculated this. The answer is no. The answer is simply no. People argue that holographic comms will require 4 terabits per second. We will use compressions. There will be the MP4s for holographic compression. There's no way a network would transmit raw data over the interface, so therefore, 10 petabits is impossible. So the question I'm posing here is the 6G really the dawn of a machine-driven area? Will it be an area where we will not define services anymore, meaning as humans? Will it be done by machines? Because if you think about it, so far it is a human engineer who has designed a service for another human or for a machine. IoT was all done by humans. But is the future going to be where machines design services for machines? And if that happens, then I see, that very discrete set of services, which we see at the moment, being replaced by a continuous spectrum of services. And that will change the game, both in the transport infrastructure, wireless infrastructure, and the hyperscalers attached to that. Very different game, right? Because a lot of thinking will be probabilistic. Our cost mapping, which is very discrete at the moment, in the RAN, will need to be changed. So I think there are fundamental things which need to be changed if we're going through this era. So I'm posing this challenge to you guys, start thinking about this, reach out to me if you want to discuss it in more details, start designing methodologies, architectures who can do that. My challenge number 2 is prepare really for quicker innovation cycles. Now, I personally have worked on this already for 2 years, and I gave a keynote on this, just on this topic recently, and also Etsy Standards has done a spotlight architecture article on my proposition to move from autonomous networks to self-synthesizing networks, right? So they're very, very different. Let me explain that to you. Autonomous networks is really about taking stuff humans have designed, throwing AI at it to configure it and run it. Okay, so if you look at the way how we really make our phone calls in the end of the day, it started with a researcher, probably in the year 2000, with a great idea. Took us 10 years to do system designs. Then we did standards and prototyping, and then we started to roll this out and configure and run it, right? So we have humans doing it first, machines taking over, okay? In self-synthesizing is very different. The proposition I made in 2018, and we worked with that with my students actually quite a lot on this, is to automate at least 2 more steps, and that's the system designs and the standards. So I've been advocating with Etsy for a while to really look into AI written standards, into AI design systems. Can we actually download, can we download an IEEE Explorer published paper and run some natural language processing on this, okay? And then we do actually extract it, we formally verify that, we build an architecture around this, we then run GANs around this. GANs are very good, the generative adversary networks, to run different scenarios, something which an engineer takes maybe years to do. A GAN can run through billion scenarios literally in a millisecond. Then you bring it over into the SON ecosystem. Okay, so the idea is my dream, and you will read that in the article on the keynotes I've given, my dream is to bring these 8-10 years down to ideally milliseconds, okay? And let's see if we can achieve that. We need you guys to help us in doing that, but start thinking of that notion of self-synthesizing networks. And we probably will start a standards initiative as well around this. But of course, that needs to be approved by Ericsson. But, I think that's the future. And the last but not least is around latency. And you will say, hey, Mischa, why do you bring up latency? We have solved latency. And I tell you, we have not solved latency. And the truth is, when we talk about low latency comms, we're talking about low latency comms over a very short distance. Now, when we networked over very short distances, we had something called local area networks, LANs, in the 90s, early 2000s, and they really have not made a difference to the economies today. Zilch. What really made the difference is the internet, when we started to connect these LANs. And when we really started to go from an intranet to an internet, this is when we did the magic. The same with the latency. I think you appreciate the importance of latency, the way how it will really transform our systems in the future. But if we really want to do it well, we need to transit from an ultra low latency to an inter ultra low latency. How do we do that? Well, here are suggestions, right? So standardized compression. We need to make sure that we get these very standardized low latency compression and cryptographic methodologies. So block codes will not work anymore. We need to replace a lot of stuff by stream codes purely because of latency reasons, which has implications on synchronization, et cetera, et cetera. Application codecs, video audio, needs to be fundamentally changed to allow for that. You will have heard of IETF standards like L4S, Scream, etc. Has to be now part of our natural network fabric. Slicing we have done. There's little to be done now, so the orchestration is being done. I don't think there's too much magic there anymore. But then there are the standardized AI, and standardized AI is something we really need to do. Okay, we really need to get this the AI standardized, and I think we'll get a lot of pushback from the hyperscalers because currently they are owning AI. It seems like they're open sourcing their stuff, but I told you before they're not open sourcing their production ready stuff. So they're owning a lot of methodologies, right? And that needs to be standardized. The same as our telco infrastructure was standardized, which allowed for interoperability, which allowed for transparency, and in the end allowed also for innovation. Okay, because in fact, if you look at the AI community, with respect to where they could be, it is a stagnant community. There's not really a lot of super exciting stuff happening, a little bit here and there. Imagine if you open up production-ready AI, really standardize it, the magic you could have. So my call is really work on this, use that AI to do a lot of predictions, beat physics doing that, by predicting stuff. So when I'm playing a game with Australia, I can actually use AI to help us, do that latency rather than 46 millisecond goes down maybe to something like a millisecond. We can do it. If the ecosystems come together, if we truly flatten that, if we open up at least the interfaces for them to talk in a standardized way, the future is really magical. So therefore, I'll leave you with these 3 challenges. And I hope I gave you a little bit of an insight into my personal as well as our community thinking on how to get in a 6G future and why we're doing that. The why is always very important. I want you to remember, always give a soul to technology, right? So that's really, really important. Thank you so much. And, I'm very happy to take any questions if there are any. Thank you.